So hi, uh, good evening to one and all. So my name is Kaushik and I'm from Civil Department of Tourism. So today the complex engineering problem on data structure is our product title is digital clock. The product title is digital clock. About the digital clock, a digital clock is a timekeeping device that displays the time in a digital format typically in minutes and seconds, hours, minutes and seconds, hours, minutes and seconds. Unlike analog clocks, which use rotating hands to indicate time, digital clocks use numerical displays to show the time. This format this format is easier to read and represent in both 12-hour and 24-hour systems. And here are some breakdowns. The digital clock using data structure, point wise, point wise report, introduction. A digital clock displays times, time in hours, minutes, and seconds in a numerical format. The clock can be implemented using various data structures to represent time, update it, and display it in real time. We will use arrays or linked lists to store the components and a simple algorithm to update and display the time. And there are some objectives. The objectives to implement a digital clock that tracks the time using data structures, updates the clock every second, displays the current time in hours, minutes, and seconds format. And third one, data structure used. Array. A simple array, hours, minutes, and seconds can, can be stored at the three time components. Example, time 0 for hours, time 1 for minutes, time 2 for seconds. And there are some linked list like linked list alternative. Each node of the list can be store a time component like hours, minutes, and seconds, as well as a queue. Queue can be used for cyclic updates like hours, minutes, and seconds in a queue-like fashion. And the time representation. Sorry, time representation like hours stored as a value between 0 to 23 for a 24-hour format. Minutes stored as a value between 0 to 59 seconds. Stored as a value between 0 and 59. Algorithm for the time management. Initialization. Set the time 000 by default. Store the time in an array or linked list. Updating the time. Updating the time. Increment seconds. Every second increment the seconds. Handle seconds overflow. When seconds reach 60 seconds, reset seconds 0 and increment minutes. Handle minutes overflow. When minutes reach 60, reset times to 0 and increment hours. Handle hours flow. When hours reach 24, reset hours to 0. Display the time. Format and display the time in hours, minutes and seconds format. Here are there is a code for this. In this code we can see in this code we can see how we can execute the code to set the time. In this we can see there are many arrays. Arrays are used and linked lists are used. So the explanation of this code is to define that it contains three attributes like hash minutes and seconds. This update time method handles two incrementation of time components. The display time method prints the current time in hash minutes and seconds format. The start clock method continuously updates and displays time every second. And there are some points of consideration to implement in implementation. As like data representation by using arrays. Short time as an array of size 3. Time 0 is equals to hours. Time 1 is equals to minutes. Time 2 is equals to seconds. Sorry. Linked list. Each component, hours, minutes, and seconds could be represented by a separate node queue. A cyclic queue could manage the time flow in a circular fashion. And next, the time handling. Each component, seconds, minutes, and hours, has a predefined range and must wrap around when it overflows, either after 59 seconds, reset to zero and increment the minutes. Real-time update. The real-time update the time slip one. The function simulates real-time updates the by pausing for 1 second before each clock update. And there are some advantages of using data structures like scalability, flexibility, efficiency. Like scalability, the clock can be extended to support more complex features such as multiple time zones, alarms, or countdowns. Flexibility. With different data structures, arrays, linked lists, and queues, the implementation can be adapted for various needs. Efficiency. The cyclic nature of time 24 hours, 60 minutes, 60 seconds can be managed efficiently using modular, automatic, or or circular data structures like queues. The time complexity is the time complexity for each clock update operation is 0, 1. Since we are simply incrementing values and checking for overflow conditions, either hours, minutes, or seconds. At last, the conclusion of the digital clock implementation is a simple, a simple but efficient way to manage and display time. Use data structures like arrays or linked lists to store time and components. Real-time updates are handled using the time slip method. The time overflow is managed efficiently, and the clock resets for a full cycle of 24 hours. At this point, a report provides an overview of the digital clock implementation using data structures, and it can be extended to support the more complex features with examples like multiple time zones, alarms, or countdowns. And it can be implemented and can be adapted for various needs, and it can be managed efficiently using modular or automatic or circular data structures like queues and arrays. The, this this reports provides an overview of the digital clock implementation using data structures. It explains the approach of code and considerations for creating a digital clock approach. And that's it. So, thank you.